Hello children, welcome back again to EDUHUNT classes. In this video, we are going to do the conclusion part of the previous separation of mixture of two miscible liquids. Okay, here is the topic for you to separate a mixture of ethyl alcohol and water. Okay, same as that of miscible liquids. Okay, they will have taken alcohol and water. No, here is the same ethyl alcohol and water, a type of alcohol and water. Okay. So now we are going to separate these two miscible liquids. Okay, we know these two are miscible liquids. Okay, ethyl alcohol and water acting as what? Miscible liquids. Why they both are acting as miscible liquids, children? Because if they both are mixed together, they will form only single layer because they both are mixing in equal same proportions. Yes, like that. Okay. Fine. So, now we will go with the next slide. Here we go. What are the apparatus required for this process of mixture of two miscible liquids? Okay, we have the apparatus. First one is taken ethyl alcohol. Okay, the name over here for you. The name is ethyl alcohol, or we can also write the name of the ethyl alcohol in simple manner, in simple laboratory name. Simple name is ethanol. What is this? Ethanol. Once again, ethanol. So, this ethyl alcohol is having a chemical formula named as C2H5OH. What is this? C2H5OH. 2 carbons, 5 hydrogens and 1 alcohol group. OH means alcohol group. Okay, we can divide this with CH3, okay, CH2OH. This is the representation of a particular formula in the IPAC one. Okay, so here we have the first apparatus, that is ethyl alcohol, also called as simply ethanol, and the formula is C2H5OH. Representation CH3 CH2OH. We can write like this also, or CH3 CH2OH. Okay, this is the representation, and first apparatus taken is ethyl alcohol. Okay, what is this? Ethyl alcohol. You know, children, girls will wear nail polish, no? Yes. So you know what thing is required to remove the nail polish from the nails? It's nothing but ethyl alcohol. Okay, we have to close it with the cap because it is a spirit kind of things. If we open the cap and leave it in the environment, it will evaporate. In the sense, it is volatile material. Okay, ethyl alcohol is used for removing nail polish things. Okay, this is small thing which we add in the nail polish remover to just, what is known as ethyl alcohol, also known as ethanol. Okay, now next apparatus taken is, what is this? Water. Very good. What is this? Water. What is the formula, chemical formula of water? Yeah, very good. H2O. Okay, water. Okay, ethyl alcohol, water, and we have an apparatus setup. In that we have different apparatus, children. Okay, in this apparatus setup we have different apparatus. I'll just name it one by one. This down one is burner. Okay, we will use Bunsen burner or the spirit lamp, right? In that case, this is a type of the burner. Okay, the switch is on. If the switch is on, it will give the flame. Okay, inside of this. Okay, and this, the round bottom and the present flask is called as distillation flask. Okay, what is this? Distillation flask. Next one, this the top of that, where you can see the inserted one with inside the particular distillation flask is thermometer. What is this? Thermometer to check the temperature. Very good. And you can see a small brown colored closed of the cap. Okay, this is called as cork. What is this? Cork, to just close the distillation flask and to insert this particular thermometer, okay, to just acting as a stable one, okay. And next, coming this side is where you can observe from this distillation flask up to here to the continuation part, the round bottomed, okay, and this is the distillation flask up to here, okay, okay, and here we have a continuation one for this distillation flask is nothing but a condenser. What is this? Condenser. And after this condenser, we have iron stand over here. What is this? Iron stand, to which the condenser is fitted properly, okay, with the clamps and all, okay. And here we have last a flask where we have to collect the given the vaporized one, that is named as receiving flask. What is this? Receiving flask, okay. So namely you have burner, distillation flask, thermometer, cork, and here up to here. Again here we have cork here, and again this is a condenser, which means it will cool the vapors into liquid state, okay. And iron stand and also clamps we have. This is clamp to just hold it tight of this condenser clamp, and we have receiving flask over here, okay. This is the apparatus and how they are set up for the particular fractional distillation process, okay. Here this is nothing but a fractionating column, okay. The distillation flask contains inside fractionating column, okay. So in some other things they will take round bottom flask, okay. If there is no use of, if there is no availability of distillation flask, they will take a round bottom flask. It will be like this with a round bottom, okay. They will take a round bottom flask like this, and to this they will insert the fractionating column, okay. If there is no availability of distillation in the particular laboratory, they will use like this, okay. To this they will add the solution and they will go on heating, okay. From this they will attach with the cork, they will attach, what is that? Wait, thermometer, okay. So but in the laboratory, if there is only responsibility of this distillation flask to be done. If it is not, we will take round bottom flask and fractionating column separately. If not, there is a same distillation flask at one particular process, okay. So here is a particular apparatus setup for you, and the apparatus required for all these things, okay, coming with alcohol, ethyl alcohol, water and all these things, okay. So how the process is going on, we will see, okay. Yeah, one more we have thermometer. We have thermometer over here. Yes, it is placed. Okay, thermometer. Okay. Actually, this is very long. It is not used to measure our fever temperatures. No. It is used in the laboratory to just insert in the liquids. Okay, just check the boiling points of the particular things. Okay, here did you see the thermometer? Yeah, the long inserted one. Very good. Okay, this is the one. Thermometer. And here the method of separating a mixture of ethyl alcohol and water. We will see how it happens. Okay. Now, ethyl alcohol and water are miscible liquids. As we know, alcohol and water are miscible liquids. Similarly, ethyl alcohol and water also two mixed one, no? So, it is called as miscible liquids. Okay. The boiling points of ethyl alcohol is 78 degrees centigrade. What is the boiling point of ethyl alcohol? 78 degrees Celsius or centigrade. Okay, here it is. And the boiling point of water is, hope you all know this, water is 100 degrees Celsius. Very good. Now, a mixture of ethyl alcohol and water can be separated by what process? Fractional distillation process. Okay, we already know what is a particular process. Fractional distillation using fractionating columns. Yes. So, we have here two temperatures. One is ethyl alcohol boiling point 78 degrees Celsius and water is 100 degrees Celsius. What is the difference between them? The boiling point difference should be less than that of 25 Kelvin, right? Okay. Here what is the difference between them? In Celsius given, Celsius is given, okay, don't worry. It is approximately 22 degrees Celsius, not approximately, equally, right? It is equals to 22 degrees Celsius, the difference. the difference in boiling point, it is given as difference in boiling points is 20 degrees Celsius. Okay. Now, continuation. The mixture of ethyl alcohol and water is heated in the distillation flask. We have taken the distillation flask, down it is round bottomed and top it is like a cylindrical manner from where it is attaching with a particular attachment with a slanting downward displacement one wise. Okay. Here we have taken the mixture of ethyl alcohol and water in a particular round bottomed the distillation flask. Okay. And there we are going to heat it that. Okay. Heat the distillation flask fitted with a fractionating column. I'll see this is being understood with the particular picture. Here it is. Okay. For example, if this is a apparatus set up in the particular laboratory, okay, here if we see, here also it is an iron stand present. What is this, children? Iron stand. To this iron stand, we just fitted the round bottomed flask and also this fractionating column. Okay. If you see, this is acting as a distillation flask over here, round bottomed flask and attached with that of fractionating column, and down we are adding with the Bunsen burner. Okay. This is the Bunsen burner, right? Bunsen burner or else the spirit lamp we can use, children. We can also use spirit lamp in laboratory if there is no requirement of, there is no availability of Bunsen burner, we can also use spirit lamp. Okay. And here for the iron stand, they attached, they clamped with, for this they with round bottom flask which is acting as a distillation flask, and to this they attached fractionating column. Okay. This is clamp. Okay. So here we are allowing the heat to be given out. Okay. Before that we have to fill this particular distillation flask with the mixture of both ethyl alcohol and water. Okay. Here we have both ethyl alcohol and water mixture over here. C2H5OH and H2O, both of them are there. Okay. And after giving the flame to this particular apparatus, what happens? The distillation flask which containing ethyl alcohol and water are allowed to heat. Okay. Both of them will lead with the heating. Okay. And it is attached to the earth of fractionating column, no? To this like this. Did you observe? Fractionating column, and upon this they added this continuation part. Okay. So what's next we'll see in the particular paragraph, right? The mixture of ethyl alcohol and water is heated in distillation flask fitted with a fractionating column. Did you understand the point? Distillation flask fitted with a fractionating column, they heated this. Okay. And the next point here is, when the mixture is heated, both ethyl alcohol and water form vapors as their boiling points approach. Okay. Because we know what is the boiling point of ethyl alcohol and water separately. What is the boiling point of ethyl alcohol, children? It is 78 degrees Celsius. Okay. And what is the boiling point of water? 100 degrees Celsius. Yes. So who will boil first? Who will start boiling first? We have mixture of both here. Okay. We have mixture of ethyl alcohol and also water. Who will start boiling first? Very good. Ethyl alcohol. Why? Because the temperature is from 0 to starting, no, 111 like that. Okay. What comes first? 78 degrees Celsius or 100 degrees Celsius? Very good. 78 degrees Celsius. Okay. First the ethyl alcohol will start boiling before that of water. So the vapors of ethyl alcohol are coming up. Did you see the particular things? Yes. So this one is going to the top of fractionating column, and here what happens? The vapors are reaching to that of the fractionating column, and here there is a thermometer which will record the temperature. Yes. So there if you see the continuation part what's going on. Okay. See here, when the mixture is heated, both ethyl alcohol and water form vapors as the boiling points are different, they are approached. Okay. The ethyl alcohol vapor and water vapor rise up in the fractionating column. So both of them will do it, but first will come is fractionating column. From what will come first? Yes, ethyl alcohol will come first. Ethyl alcohol vapors will come first, okay? And later water vapors comes, okay? And the upper part of the fractionating column is cooler. The upper part of fractionating column is nothing but cooler. Here we have a cool, because why? Here it is completely hot, okay? The apparatus is very hot here, okay? But going up it is having the coolness, okay? We have here cool part over here, okay? And later we have condenser too, okay? Here it is somewhat cool. The top part of the fractionator is somewhat cool compared to that of the down part, okay? Next. So as the hot vapors rise up in the column, okay, the hot vapors will keep on rising one over the one in the particular column. The hot vapors are reaching from here to, yes, they are going and reaching to the top of the fractionating column, reaching up, and here they will have the presence of cool, because why? It is completely boiled, heated up, going up, and here the vapors will get cooled down, okay? Yes. Now next, okay, so here we have the upper part of the fractionating column is cooler and the hot vapors are rising up in the column. They get cooled, they get condensed, and they trickle back into the distillation flask, okay? They will go up, children. Keep on, the vapors are going up, they will just have the cool presence, yes, again it will condense. Here we have condenser, you observe here. From here we are going to give the cool water in. Which water? Cool water in, and here we observe the hot water out. Condenser, no, it will cool the vapors, okay? This is acting as a condenser, and we attach to this of the fractionating column, yes. So from here the vapors are coming back to the condenser, where it will cool down and the vapors will form as a droplets, and they will fall in this particular receiving flask, okay? So this is what happened. Because of this condenser, the hot vapors which rise first, what are those? Very good. Ethyl alcohol vapors are going up and they are being condensed to get a liquid form. So gaseous to liquid. So what is coming first? What is filling first in the receiving flask? Which vapors are those? Ethyl alcohol vapors are being condensed to get a ethyl alcohol in liquid form. Yes, from gaseous to liquid form. This is called condensation, right? Yes. This is what happening, children. And after this collection of ethyl alcohol in which flask? Receiving flask, we can separate this. We can take out, and we can also keep another receiving flask to just absorption of water. Because why? Ethyl alcohol will go first, vaporizes, condenses to get liquid, and what's coming next? At 100 degrees Celsius, what's coming next? Water. Very good, okay? Also water will go, vaporizes, condenses to get water, okay? But here the fumes which have come free of first, what is that? That is nothing but ethyl alcohol, right? Those are the first fumes arised here in the particular distillation flask, that is pure ethyl alcohol vapors, okay? This is pure ethyl alcohol or ethanol vapors. So this will comes first, okay? Vaporizes, condenses and liquefies to get liquid form, okay? This is called as distillate. What is this? Distillate. We are receiving this in which flask? Receiving flask. We have your iron stand, clamp to just hold the particular the tube of the condenser. Okay, children, this is all about the process of the fractional distillation, where we are using this Bunsen burner as a heating lamp, okay, and iron stand for the holding of the this particular distillation flask, and we have fractionating column, okay, and cork, thermometer, condenser, where water, cool water and hot water out is coming outside, okay, and we have here the iron stand again. This is the receiving flask where we are going to receive the ethyl alcohol vapors first, okay, clear, no? Okay, we'll see the continuation. As experiment goes on, the fractionating column warms up. Children, as we know, as experiment is going on, because of the more heat, the fractionating column will warm up. This one will be also getting the warmness. Yes, warms up by the heat released by the condensed vapors, because why the vapors are very carrying the hot vapors, no, it will condense. Okay, it will also go with the vapors. After some time, a temperature at the top of the column being much less than that at its bottom. When the temperature at the bottom of the fractional column reaches 70 degrees Celsius, the ethyl alcohol vapors passes through the condenser, gets cooled and collects in the beaker kept at the end of the condenser. We already saw this, no? If it reaches 78 degrees Celsius, it will go condense and form as liquid form. Okay, and the ethyl alcohol water mixture is kept boiling such that at a rate that the thermometer shows the boiling point ethyl alcohol what? 78 degrees Celsius, and in this way we are going to separate the ethyl alcohol, distills over and gets separated. So what's coming first, children? What's coming first? Ethyl alcohol, right? So there we are just noting on the temperature. What is that? 70 degrees Celsius, where we are going to first distill the particular ethyl alcohol first, because the vapors are coming first and collecting because of the condensation. Okay, and later what is happening? We are going to collect if presence of water. Okay, we can going to collect the water also. So here is that process, and one more picture for you in detail. Okay, the round bottom flask, the spirit lamp, we are going to heat it up. Okay, and what happens? The mixture where the ethyl alcohol and water are present, water and ethyl alcohol solution. Okay, and if you start giving heat, what happens? Yes, it will, the ethyl alcohol vapors will come first, that is pure ethanol vapor. It will go up. When the temperature of the thermometer reaches 70 degrees Celsius, it will go to the condense. Okay, and it will falls with the droplets. Here it is which form? Gaseous form. Here it is liquid form. Okay, from gas to liquid, which process? What is the name called as? Very good, condensation. So what is being condensed over here? Yeah, the condenser is allowing the gas to get into liquid form. Okay, here we have the water in and the water out, the corks present and the clamps present. Okay, this is called as beaker, but in the previous slide we just saw it is in the conical flask shaped as a receiving flask. This flask is having name, children. This flask is having with a conical shape. Okay, conical shaped flask, conical shaped flask. Okay, and here it is beaker. Okay, beaker, where it is acting as a receiving flask. Okay, because of the availability of the apparatus in the particular laboratory, we will use simultaneously. Okay, here is a process, round bottom flask, where the mixture of water and ethanol are being added. After giving the heat, the pure ethanol vapors arises. Okay, and that reaches the top of the column, fractionated column, where the thermometer is present. If the thermometer is showing reading up 70 degrees Celsius, okay, these vapors are allowed to cool. Okay, because why? Because ethyl alcohol has 70 degrees Celsius boiling point. Yes, so they are going to condense it to get a liquid form of ethyl alcohol the last. Okay, so if you do this process, if you separate the ethyl alcohol separately, and what next? Water. Again water vapors. If it reaches 100 degrees Celsius, if it reaches 100 degrees Celsius, it is allowed to condense and cooled to get water in another beaker. Okay, collected separately after ethyl alcohol, simply called as ethanol. Okay, this is what happening in the process of fractional distillation. Okay, where we can see, observe it, the mixture of two miscible liquids are being separated by the process of fractional distillation. Fraction wise we are going to distill it. Okay, first we are going to distill ethyl alcohol, and next is with water. Okay, one by one, because those both are mixture form or solution form, we have to separate it differently. Okay, because of the boiling point difference, we are going to do it separations. Okay, so first is like this, and other step we can do it with the water presence, same process. Okay, children, but the difference should be, boiling point reading should be 100 degrees for water. Okay, This is all about the process of separation of a mixture of two miscible liquids. Taken here are ethyl alcohol and water. Okay, this is all about the process, and hope you understood. And here is the session, children. Thank you.